Hey guys, welcome back to another video. Today I have another aircraft transponder to take apart. This is a RT-18D UHF FlightFone transceiver that was made by Wolfsburg. You can see it weighs about 7.5 pounds. We have a really old Duncan Aviation tag on here. We also have another tag here that says it was released to service with software revision E. I'm not exactly sure what aircraft this was installed on, but I do know it was on a business jet that was probably made around the late 70s or early 80s. So this transponder here is part of a flight phone system that was used on some business jets. It allows passengers to make phone calls to the ground while in flight using a telephone in the cabin and this transponder to communicate with ground stations. The connectors are located on the front of the box. We have our two data connectors and our high frequency antenna connector here. The construction of this box is a little bit different than the other ones I've taken apart. We're going to first need to take off this bottom piece of aluminum, which is screwed on with 3 screws on each side. Now I can just pull it off, revealing what's underneath. Alright, so here's what we have underneath. We have some wiring harnesses. We have several coax wires here. Looks like we have some sort of adjustments here for a variable component. We have 4 turquoise connectors, which look like we're going to have PCB cards on the other side connected into them. We have a capacitor here that's connected to ground. We have a big power resistor here. And it looks like we have some connections going into this box here on the side. On the bottom here we have a transparent relay, which you can see inside of, which is pretty cool. You can see it's connected in a weird way that I've never seen before. This is basically just a connector that they're using to connect to the leads of this transistor here. We have a power resistor over here, which is 0.68 ohms, and we seem to have the bottom side of some sort of cavity or chamber or something on the bottom here. You can see some of our high frequency wires here are the solid type. We have some over here too. Alright, now the next thing to do is to take off this main cover here, which we can take off by taking out all these screws on the top. Alright, so I've taken off the screws and now we can take this cover off. And here's what we have underneath. We have some shielded boxes here, circuit board, and another circuit board over here. And it looks like we have another one here. And then I think this here is our main amplifier cavity. Alright, so let's take a look at this board here. This is the synthesizer board. First we can see we have all these trimmers here. We have 12 of them. I think these are for adjusting channel frequencies. It does say channel frequency adjust under here, so that's probably what they're for. Underneath the adjustments we have a shielded box, and underneath that we have a row of capacitors and resistors. Over here we have various other components. We have a few ICs, a few transistors, some capacitors and resistors. We have a whole bunch of these red adjustable inductors here. Looks like we have another trimmer here, but it's just in a different package. And we have these 2 IC chips here. Okay, to take off this PCB card, we have to take out this screw here, and a few screws on the bottom here. Alright, so now we can take this board off. On the back here you can see the connectors which go into these sockets here. Alright, it looks like I'm going to have to take off this aluminum backplate here. Alright, so here's what we've got on the back. We have some nice decaying foam here, of course. You can see this board here is hand traced. We have a solid high frequency wire here soldered onto this ground plane. You can see that these 2 outer connections here are ground, and those go to the large sections of ground plane around this board. You can see over here in this section that the traces are lifting off the circuit board a little bit. Now we can take off the screws to take off this aluminum cover. Alright, so let's see what's under this aluminum cover. Of course, we've got some more decaying foam. It looks like this here is a cover that we can take off. And under here we have some crystal oscillators. So these crystal oscillators go in order from 213 megahertz to 201 megahertz. And each frequency is probably for its own channel, which can be fine adjusted by these trimmers here on the top. Alright, next you can see our main logic board here. We can also see the wire loom over here that goes to the connectors. This board does have a label on it that says logic. We have two large logic chips here, and these two chips are EEPROMs. You can tell because they have a sticker over the exposed die, and you can see what software revision is on them. You can also see that these EEPROMs here are actually socketed. That is so they can be taken off and new software can be flashed onto them. We have some more logic chips over here and over here, along with some resistors and capacitors. We have a few transistors scattered around here. We have this blue trimmer here and 3 crystal oscillators, 2 up here and 1 down here. So let's take this board off. It is attached with a screw on the side and screws on the bottom, similar to the other board. Alright, so here's the board. I've also taken off the back plane here. You can see this board here is double-sided, unlike the other board. And you can see this board was not traced by hand. These chips here have a date code of the 36th week of 1984. And most of these other chips are also from 1984. But next, let's turn it around and look at the other side. First, I will take out all these screws that's holding the cover on this module here. Alright, I've taken out the screws so we can take this cover off. And here's what we've got underneath. We have some high frequency stuff. You can see we have adjustable inductors here. That's what these big screws on the bottom here are for. You can see we have other components like transistors, resistors, and capacitors. I see that they're using just these metal bars here for making connections between components. We can also see 5 variable air gap capacitors, which are these components here. On the top of this module, we have a high frequency connection here. We also have another high frequency connection to that module back here. You can see the connector behind the wires here. We also have a third high frequency connection going to this box here. This solid high frequency wire here goes down and connects to this module as well. Alright, now let's take this cover off. Okay, here's what we have underneath. You can see this metal box is made out of some very thick machined aluminum. We have 6 more variable air gap capacitors, which can be adjusted by turning the screw head here. By changing how much of these metal plates are close together, we can adjust the capacitance of the component. We also have 3 transistors here. And it also looks like they're using more of these steel plates to make connections between components. We have 2 more transistors on this side, 1 over here and 1 up here. We have some interesting looking resistors here, here, and here. We have a few more carbon resistors in here and a few capacitors. You can see on the bottom here the high frequency connections going into this module. They connect here and here. Alright, and the last thing to do on this side is to take off this circuit board here. Alright, now we can take the board off. I've also removed the aluminum backplate. Here's the back side of the board. It's nothing really too interesting here. We have a big bandpass filter here that's in this metal box. You can also see that we have a lot of carbon resistors and capacitors on this board. We have 4 logic chips here, and we have a trimmer here and here. We also have 3 variable inductors, 1 here, here, and here. And that's about it for this board. Alright, the next thing I would like to do is take off these 2 modules. There are several screws holding each of them on. We have some up here on this side and on the bottom here. Alright, so after very carefully removing many high frequency connections and many screws, I have taken these modules off. Unfortunately, each of these modules is connected to the wiring harness with one small wire. Same thing with this one here. You can see the backs of these. We do have some capacitors on the back here and a few resistors. Here's what's on the back side of that other module. You can see the 3 high frequency connections here. We have a few capacitors and resistors on the back of this. On the back of both of these modules, we have these really strange circular components. They are soldered on to the metal with another connection on the top of the component. You can see that they do have color codes on them for marking the specifications of the component. Alright guys, so it looks like I'm actually going to have to take this part off first in order to get this module out. I do believe that this is the power supply section, so let's take it apart and see what's inside. Alright, it looks like we have 7 screws back here holding it on. So let's take out these outer 4 screws first, and then we'll take out the other screws. Alright, so I've taken the screws off, and now we can pull this cover off. And inside here we have a power supply circuit board. You can see a whole bunch of thermal paste on the back of this aluminum piece here. Okay, so we have a big power transistor here mounted on this aluminum block here. You can see that there's thermal paste on both sides of it so that it can make contact with this aluminum piece. For some reason, they've also added a massive amount of thermal paste to this inductor here, which I don't know why. That's kind of weird. And I can tell it is thermal paste because of the way it gets on my finger when I touch it. This board is actually using a connector to connect to the rest of the module, so I can actually pull it out like this and unconnect it. You can see there's 3 connectors here, and here's the back side of the board. I can see a little bit of lifting of the traces here. You can see there's screws on the back for holding on the power transistor and the inductors. You can see here we have one labeled 14 volts and one labeled 28 volts. And this middle one here must be ground. 28 volts is pretty standard for aircraft systems. It probably takes in 24 volts and converts it to 14 volts. You can see that we have 2 big capacitors on the bottom. We have 2 smaller caps here that are glued together. We have a transistor here. There's our main power transistor again. We have a big diode up here and some resistors and capacitors around here on this board. And so that's about it for this board. Now that the power supply is off, I can actually get to the screws holding on this last module here. Alright, now we have some more screws to take out. On each side we have 4 screws going into this module that need to come out. Okay, so the next thing we need to do is unscrew this nut here, which is connecting the high frequency connector onto this module here, because of course this is permanently attached with these solid high frequency wires here. Now we need to take out these 4 screws holding on this metal front plate. Okay, now with those unscrewed, we can take off this front plate here, just like that. But of course, before we can take the module out, we have to take off this high frequency connector here. Alright, so I've finally got this module out, so let's begin to take it apart. The first thing that I want to do is take off this cover here, which is held on by 5 screws. So here's what we've got underneath. We have a little bit of circuitry here and then some strange blue component here. I'm not exactly too sure what this blue component is. My best guess is that it's the high power, high frequency amplifier for the transmitter. Looks like we can take it off if we take out a few screws, so let's do that. Okay, so I've taken it off. You can see that there is thermal paste on the back of this, which does suggest that it's the high frequency power amplifier. You can see that these solid pieces of coax are soldered together, and we have one piece of solid coax here that doesn't really go to anything. And it looks like we only have 4 connections going to this power amplifier here. So now I'm going to start taking apart this module here. I believe this is some sort of cavity I find it strange that we have two high frequency wires connecting to this connector here. We also have these strange loops here. We have 3 of them. You can see that we've got a whole bunch of screws holding it on. So all the screws are out, so let's pull this out and see what we've got. That's weird. Look at that. What's in here? Oh, this is neat. So it appears to be some sort of high frequency, like resonance cavity of some sort that uses some sort of resonant frequency or something to do something. I don't know. This is very strange stuff. You can see that these long bars go all the way to the other end, and there's like these metal bumps inside, and it looks like these metal pieces in here actually go into these holes here, kind of like a connector. So it goes in like this, and those connect. You can see here we have these little screws here for some sort of adjustment. You can see that these screw in and out to adjust like the resonance frequency or something. You can see these are the back sides of them, and they are connected to here with a small little strip of metal. And it looks like these parts are ceramic, and we have in total 3 of them. You can see on the other side we have tons and tons of screws. Alright guys, so I've taken all the screws out. You can see these are all the screws here that I had to take out for that piece. And here's what we've got. These big long pieces of metal of some sort. Then here we just have like a big piece of heavy extruded aluminum. Here you can see how the 2 parts connect up, just like that, and it would be like this inside. It's pretty neat. I can't even begin to imagine all the math and engineering that has to go into figuring all this stuff out. It's quite complicated, quite expensive electronic equipment. These pieces here almost look like they're made out of silver. You can see that there's brass pieces on the end here, and they are soldered to this back metal piece here, and that's where all the screws were. So that's about it for this teardown. I hope you guys learned something, and of course, thanks for watching.